Hi folks, welcome back to the channel. I'm here with the Vaonis Vespera Pro. Vespera Pro is the newest, most advanced smart telescope from Vaonis on the market today. And in this particular video, we're going to take a look at the technical specifications of this telescope. And of course, we're going to image the sun, the moon, and some deep sky objects to find out what the Vespera Pro is all about. Let's go! The Vaonis Vespera Pro doesn't come cheap with a starting price of €2,790 or dollars. That's significantly more than its more affordable sibling, the Vespera II, which is available for about €1,590 or dollars, which I reviewed about a year ago. You can find my review of the Vespera II along with links to reliable telescope shops that sell the Vaonis Vespera II and Pro in the video description below. The Vespera Pro comes in an excellent hard-shell case with a lock to prevent theft, as well as a mini tripod for easy setup. If you're willing to spend even more, the Cosmic Bundle, priced at €3,349 or dollars, adds 3 specialized filters: a solar filter for safe solar viewing, a light pollution filter to improve performance in urban areas, and a dual band filter that captures specific wavelengths emitted by ionized hydrogen and oxygen in emission nebulae while blocking out other light for maximum contrast. Looking at the technical details, the Vaonis Vespera Pro is the newest addition to the Vespera lineup, featuring significant upgrades compared to its predecessor, the Vespera II. Both Vespera telescopes feature a 50mm f5 quadruplet refractor telescope with SFPL52ED glass, ensuring sharp and color-accurate images. However, the Vespera Pro introduces a new Sony IMX676 camera sensor, delivering a 12.5 megapixel resolution of 3536 by 3536 pixels, compared to the Sony IMX585 sensor found in the Vespera II, which had an 8.3 megapixel camera sensor. The Vespera Pro delivers a finer image scale of 1.6 arcseconds per pixel compared to the 2.39 arcseconds per pixel found on the Vespera II. This places it within the ideal 1 to 2 arcsecond range for deep sky imaging. It also features a square field of view of 1.6 by 1.6 degrees. That's about 3 times the size of the full moon in both directions. Vaonis was one of the first to introduce Covalens, an advanced Mosaic mode that expands the field of view to 3.2 by 3.2 degrees, which enables you to capture a stunning 50 megapixel image of the night sky. The Vespera Pro provides 225 gigabytes of internal storage, which is significantly larger than the Vespera II's 25 gigabytes, which allows you to store more images and additional data on the native memory card of the Vespera Pro. Additionally, the Pro's battery life is nearly 3 times longer, with 11 hours versus 4 hours on the Vespera II. Both Vespera telescopes are controlled using Vaonis' Singularity app, which wirelessly connects the telescope to your smart device over Wi-Fi. The Singularity app is available for Android and iOS devices. Both the Vespera II and the Pro have a USB-C port to recharge the telescope. Alright, enough tech talk. Let me show you how to connect to the telescope at my first attempt to image the sun using the Vespera Pro. You can turn on the Vespera Pro by pressing the large white button. It will flash 3 times and then blink red. Next, open your phone or tablet's Wi-Fi settings and connect it to the Vespera Pro's Wi-Fi signal. Once connected, launch the Singularity app and the app will automatically recognize your telescope. Singularity app is very easy to use, even for complete beginners. The app's main screen offers valuable features, including weather updates, astronomical events, articles, and a variety of options for selecting objects for live stargazing and imaging. We'll go through each of the options in this review, starting with the sun. To begin solar imaging with your Vespera Pro Smart Telescope, tap the solar button on the main screen to switch the telescope to solar imaging mode. Singularity app will remind you to use the solar filter and ensure the telescope is level, so double-check your setup before proceeding. The telescope will automatically move its arm by 45 degrees to prepare for solar imaging. Now, place the solar filter in front of the telescope lens, which is easy to do thanks to the convenient click system. The Vespera Pro will detect which filter is in place, ensuring everything is set up correctly. Next, point the telescope directly at the sun. The app will guide you, but remember to keep the tripod level and never look directly into the sun yourself. It's safest to sit behind the telescope in the shade while positioning it. Once the telescope is properly aimed, tap Confirm Arm Position to let the Vespera Pro know you're ready. The telescope will automatically point and focus on the sun. This will take a couple of minutes, in which the app will show you some information about the sun. After a short wait, you'll see the Singularity logo turn blue, and the Vespera Pro will provide you with a live image of the sun on your smart device. The live image of the sun appeared well focused in the Singularity app, and I was lucky enough to see some sunspots that day, which was a nice bonus. The solar mode offers a couple of interesting features. One of them is Solar System mode, which lets you compare the apparent size of the sun by selecting different planets. The farther away the planet, the smaller the sun appears. Selecting Venus or Mercury, the closest planets to the sun, resulted in a significant increase in size as compared to selecting Earth. Interestingly, these images are displayed in a grayscale format. But when switching back to the main screen, the sun is shown in color, and you can pinch to zoom in directly using your smartphone screen. Next, I tried out the Share button, which allows you to post a live photo of the sun straight to social media. It worked well, but the only downside is that while connected to the Vespera Wi-Fi, there is no internet access. It would be great if Vaonis added a way to link the Vespera's Wi-Fi to your home network, like some other smart telescopes can do, so you would be able to remain connected to the internet. Linking the Vespera Pro to your home network would also extend its connectivity range. Right now, the built-in Wi-Fi reaches about 10 meters, so you need to stay nearby to stay connected. However, the telescope does keep working even if you disconnect. You can walk away, return later, and reconnect to its Wi-Fi signal, and the Vespera Pro will still be tracking the sun, the moon, or any object you started imaging earlier. The information button in the app gives additional details about the sun. The menu button in the top right of the app provides options to refocus the telescope and save a photo. Interestingly, exporting to TIFF, a higher quality format, is grayed out, meaning that all solar images are saved in a lower quality JPEG format. For more experienced solar imagers looking to stack multiple photos in software like AutoStacker, there is a way to automate this process. By going to the main screen of the app, tapping on the Vespera image, selecting Image Formats, and switching Live Images on, every live image the Vespera takes will be saved in a separate folder you can then download for post-processing. However, what's missing, at least in my opinion, is an option to capture high-quality AVI or SER videos or a higher quality FITS file format, which are the preferred formats for advanced solar processing. If Vaonis included these options, the Vespera Pro could become a viable alternative for dedicated solar imagers who want a more convenient setup than their traditional astrophotography rigs. These are the main options available in solar mode. The Vespera Pro did deliver a sharp and detailed live image of the sun, which was pretty impressive. To stop your session, simply click on the Stop button and the Vespera will stop tracking the sun and finish the session. Here's a processed picture from the JPEG images I captured. The sunspots are crisp and clearly visible. Overall, I had a great sun gazing experience with the Vespera Pro. Alright folks, the weather has been pretty cloudy in the Netherlands lately, but let's hope for some clear skies tonight so we can also capture the moon and some deep sky objects using the Vaonis Vespera Pro. Before heading into nighttime viewing, the Vespera Pro needs to be initialized. Fortunately, this is a quick and simple process. Just tap Initialize next to the Vespera image on the main screen of the app, and the Vespera Pro will automatically point to the sky and run a series of calibration and autofocus routines. After just a couple of minutes, it's ready to go. When it comes to stargazing, there are plenty of options to explore. I tapped the planetary icon at the bottom of the app, which opened a selection of different categories, including galaxies, nebulae, and the solar system. Selecting any of these categories reveals a list of objects to observe. For example, choosing solar system brings up the planets, the moon, and even the sun as viewing options. On the main screen, the moon was also highlighted as a recommended target for that night. I tapped on Moon and then Observe, and the Vespera Pro automatically slewed to the moon, focused, and displayed various details about the moon. Within a minute or two, a live image of the nearly full moon appeared on my screen, and it looked pretty good. The live view of the moon allowed me to zoom in by pinching my screen and capture a photo by clicking on the photo button, which was instantly saved in the app. I pinched and dragged the live image on my screen to look at the moon, and the live view looked very crisp and clear. Tapping on the top right menu revealed the same options to those in solar mode, such as refocusing and saving a photo. However, just like in solar mode, the option to export TIFF images was grayed out, and there was no option to record a video. For solar system objects, it seems the Vespera Pro is limited to capturing JPEG images. Clicking on the information button gives you lots of information about the moon, and clicking on the share icon allows you to share a live image of the moon. After observing the moon for a few minutes, I ended the session. Here's an unprocessed single JPEG photo, and here's a processed stacked photo of the moon after stacking some live JPEG images which were automatically captured as I turned on the Save Live Images option in the Image Format menu. The quality of the photos were pretty good. Next, I moved on to Jupiter, which was mentioned as another recommended object for that night. After selecting Jupiter and tapping Observe, the app displayed a warning. Jupiter was close to the moon that evening, which might affect visibility. I decided to ignore the warning and tapped OK. The Vespera Pro swiftly slewed to Jupiter and displayed various details about the planet while preparing the live view. The whole process took about 2 minutes. At a 200mm focal length, Jupiter appeared as a small dot in the night sky. But after pinching to zoom in, I could make out the two main cloud bands of Jupiter, which was a nice touch. However, for those new to planetary imaging, it's important to note that you'll need a larger telescope with a much longer focal length to capture detailed surface features of planets. One limitation of the Vespera Pro is that exposure and gain settings are fully automated with no manual adjustment options. While this makes things easy for beginners, I did miss the ability to increase exposure, which would have helped to reveal Jupiter's Galilean moons. The viewing options in the Singularity app were similar to those for the moon, refocusing and taking JPEG photos, but again, no options for video capture or higher quality fits stacking or processing. Here's a single, unprocessed photo of Jupiter, and here's a processed, stacked photo. Yeah, not exactly something to write home about. Let's move on to capturing deep sky objects with the Vespera Pro. Before we dive into the objects I captured, let's take a quick look at how you can fully automate your imaging night with the Vespera Pro using its planning feature. To get started, tap Create a Plan or the planning icon at the bottom of the app. Then simply select your location, date, and the time you want your Vespera to start and end your imaging plan. The app will suggest the best objects to capture that night, or you can search for a specific object by tapping on the magnifying glass and entering its name. When you select an object, you will see an arc displaying its position in the night sky throughout the night. Ideally, you want to image when the object is at its highest point in the sky, as this minimizes atmospheric interference and gives you a sharper image. The interface is super intuitive. Just tap on the object, then adjust the timeline to set your image duration, and once that's done, you can add another object with its start time automatically following the previous one. Simply repeat this process until your entire night is planned out. Another fantastic feature of Vaonis Vespera telescopes is its Covalens mode, also known as Mosaic mode. Simply select an object and tap Advanced. You'll see a graphic representation of the object's size and shape, helping you to frame your shot. With Covalens, you can rotate and enlarge your field of view up to twice the width and height of the camera sensor. Just pinch, rotate, and drag the object on your screen until you're happy with the composition. Another great feature is the ability to explore constellations. When you tap on the constellation of your chosen object, you'll see other visible deep sky objects within that same area. This is a great way to discover new objects well beyond the well-known ones and expand your astrophotography journey. Alright, enough talk. Let me show you the DSOs I captured with the Vespera Pro. First, I wanted to capture the Orion Nebula, also known as Messier number 42, one of the brightest and most well-known stellar nurseries in the winter sky. I selected M42 and the Vespera automatically slew to the object. After about 2 minutes, it began capturing and stacking 10-second exposures. Since I'm imaging from an urban Bortle Class 8 sky, I used the light pollution filter to enhance the image. Also, I should mention that my seeing conditions are far from optimal. This whole month we've had intermittent clear skies and clouds, making imaging a bit of a challenge. The app automatically started stacking 10-second exposures, and after about 10 minutes or 60 stacked images, the Orion Nebula in the Singularity app was already looking pretty stunning. If for any reason you're not happy with the framing, you can simply tap on the reframing icon at the bottom of the app to adjust the object's position. The top menu also offers useful options like refocusing and saving an image of your object. But one of the most powerful features is multi-night mode. By enabling multi-night, you can pause your imaging session, for example, if clouds roll in, and then resume on another clear night. Just open the multi-night menu from the main screen, select your object, and continue where you left off. Over a few intermittently clear evenings, I managed to capture about 1.5 hours of 10-second exposures on the Orion Nebula. I saved the individual JPEG photos, and here's how the image progressed across nights. And after a bit more processing, using the 16-bit TIFF file, this is the final result. I'd say this is a pretty amazing image, especially considering my urban skies and unpredictable weather. I also captured the Rosette Nebula, and this time I used a dual band filter. The Rosette is an emission nebula filled with ionized hydrogen gas, which emits light in the deep red part of the spectrum, and the dual band filter helps to isolate this specific wavelength along with doubly ionized oxygen. By blocking out other light sources, the filter enhances the contrast and detail in the images. It was extremely humid that night, and despite the Vespera Pro's built-in dew heater, the dual band filter still fogged up. Nevertheless, I managed to capture about an hour's worth of 10-second exposures. Here's a time-lapse of the stacked images, and here's my final processed picture. Not bad for just 1 hour of imaging. Next, I turned my attention to M13, one of the largest globular clusters in the Hercules constellation. This dense collection of ancient stars dates back to some of the oldest in the universe. For this one, I didn't use any filter whatsoever, just the Vespera Pro on its own. After about 30 minutes, I had a solid stacked image in the app. Here's a time-lapse of the stacking process, and here's my final image. Pretty nice. Finally, I imaged the Horsehead and Flame Nebulae, once again using the dual band filter since both are rich in ionized hydrogen gas. This time, I enabled the Mosaic mode to capture a wider field of view around these nebulae. One cool feature is that the app visually tracks how many times each section of the mosaic has been captured using a numbered rectangle at the top of the screen. Mosaics take more time because the Vespera needs to image multiple sections of the sky and integrate them. After about 2 hours, I wrapped up the session. Here's the time-lapse video of the mosaic stacking process, and here's my final processed image. You can see that more imaging time would help to smooth out the details. Also, because the Vespera Pro is limited to 10-second exposures due to its LS tracking, capturing fainter nebulae can be challenging. Still, the Horsehead Nebula, although small, is clearly visible in the final result. Overall, I had a great experience using the Vespera Pro, but is it worth getting one? Let me give you my final thoughts. Let's start with the pros. The Vespera Pro features a quadruplet apochromatic refractor delivering flat field across the entire image, even with larger sensors like the Sony IMX676. With its Covalens Mosaic mode, it can capture an impressive 3.2 by 3.2 degrees of the night sky at 200mm focal length and a 1.6 arcsecond per pixel image scale. This results in sharp, well-corrected astrophotos that stand out as compared to some of the cheaper smart telescopes. The Singularity app is incredibly intuitive and perfect for beginners. No astrophotography experience? No problem. Just set it up, press the power button, connect to the Wi-Fi signal, select an object, and let the telescope do the rest. Finally, the build quality is excellent. It's a sturdy, modern design and it comes with a high-quality protective case. The internal battery lasts 11 hours, which is more than enough for a full night of imaging, and with 225 GB of onboard storage, you can capture multiple deep sky objects without worrying about running out of space. Now, let's also talk about the cons. Azimuth altitude tracking limits the exposure time of the Vespera Pro to 10 seconds, which isn't ideal for capturing fainter nebulae or galaxies. A dedicated equatorial tracking option would solve this, but would add complexity for beginners. For advanced astrophotographers, the lack of high-quality video formats like AVI or SCR for solar, moon, or planetary imaging is a drawback. Similarly, no FITs or TIFF files for solar system objects means limited options for stacking and advanced processing. To be fair, FITs and linear TIFF files are available for deep sky imaging. At 200mm focal length, the Vespera Pro isn't suited for detailed planetary imaging anyway. For that, you'd need a longer focal length and larger aperture telescope. There's also no manual control over camera settings like exposure or gain, so if you wanted to tweak the settings to, say, bring out Jupiter's moons, you're out of luck. And finally, there's the price. At €2,799 or dollars for the base model and €3,349 or dollars for the Vespera Pro with its filters, it's a serious investment. If you're okay with a lower resolution, less storage, and a shorter battery life, the Vespera II at €1,590 or dollars is a far more budget-friendly alternative. Another option would be to invest in a dedicated equatorial mount, a telescope, and an astro camera, which gives you more flexibility and higher quality imaging, but comes with a much steeper learning curve. So, is the Vespera Pro worth it? Well, if you want a high-quality, fully automated astrophotography experience with minimal effort, then perhaps yes. If you're looking for a deep customization and higher-end imaging, you might want to explore more traditional astrophotography setups instead. Let me know your thoughts in the comments and I'll do my best to answer your questions. You've been watching Wido's Astro Forum. I'm Wido Ulemans. Clear skies.